Hello, Matt G for IYT here. Today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 31, which reads, which of the following is not a type of balun? Is it A, transformer, B, sleeve, C, differential, or D, choke? And hopefully you will recall that a balun is a device for converting between a balanced and an unbalanced system. So think going between a coax feed and a ladder line, or you may have a balun at the feed point of a dipole antenna, so you convert from your unbalanced coax feed to your balanced antenna. Let's flip over to the full license manual, and we can see here we've got a great diagram of showing what a balun is doing, going from this balanced, where on the balanced side we effectively have a copy of the signal. Each side is the opposite of the other side, and that allows us to more easily reject noise. On the unbalanced side, we have the signal going through the center of the coax, and ground is on the outside, and that shielding on the outside of the coax can also help to reject QRM. They both have their advantages and disadvantages, but we often need to convert between them. And we've got some good examples here of some baluns. We can see here we've got some transformer baluns. So this is typically where you want to transform the impedance. For instance, well, this one is actually a one-to-one balance. There's no impedance transformation happening here, but in this one we're going from 4 to 1. So this side, this unbalanced side here, put U there for unbalanced, maybe 50 ohms, and then on this side we can multiply that by 4, so we have a balanced 200 ohm system on the other side. And a transformer balun may look something like this. So if you have like an end-fed half wave, this looks like it's maybe a 4 to 1, so maybe used for a dipole. Typically have the transformer wound around a ferrite like that. We have our unbalanced input on the bottom here with the SO239 connector. We've got our balanced output on top, and we can also see here a diagram of a sleeve balun as well. So a sleeve balun is another type, and this is I've not really played with these, so not overly familiar with how they work, but we effectively have this. It sort of goes around the coax like this. It forms a sleeve, and that can be used again to convert from a unbalanced to a balanced system. And found a nice picture of a sleeve balun here, and we can see this one's constructed with ferrites. And I think the sleeve needs to be around a quarter of a wavelength of the frequency of interest. And so let's take a look at another kind of balun as well. You may be familiar with this. This is a choke balun. Looks very similar to our transformer balun, but this kind of balun can be used quite effectively to get rid of noise, or QRM rather, coming in on the outside of the coax. So there's 3 types. So we've looked at the transformer balun there. We've looked at the sleeve balun, and we've looked at the choke balun, and that leaves us with differential as our answer. And it is, in fact, differential is not a type of balun, but it's worth familiarizing yourself with these types because they are, as well as being very useful, as part of the full syllabus. Let's take a look at the answer, see if we got that one right. And we can see that for 31, it is, of course, answer C. Differential balun is not a thing. Thank you very much. I'll catch you for the next one.